Alright, this is Geometry, section 6.6, part 2, kites. You're probably used to thinking about a kite as something that looks like this, with a tail that's up in the air and you fly it. But the formal definition of a kite is it's a quadrilateral. We've learned about a bunch of different quadrilaterals. This is the last one we're going to learn about in this chapter. So quadrilateral with two pairs of consecutive, which again means right next to each other. So two pairs of consecutive congruent sides. So unlike a rectangle or any parallelogram where the opposite sides are congruent to each other, in a kite, the consecutive sides are congruent to each other. So if we look at this kite right here, this side is congruent to this side. These two are right next to each other. And this side is congruent to this side. These two right next to each other. But the sides across from each other or opposite from each other are not congruent to each other. So there's two different ways to think about a kite because these are much different than the ones we've been learning about. They're a little bit confusing. So a kite, one way to think about it is that it's made up of two congruent triangles that share a common side. So if we look at these two triangles, the top one that's shaded is congruent to the bottom one that's shaded because this side is congruent to this side is congruent to this side, and this side in the middle, the common shared side, is congruent to itself. It's a reflexive side like we've talked about. So these two triangles would be congruent to each other by side, side, side. A different interpretation is that a kite is made of two isosceles triangles that share a common base. So this would be the base of the triangle. This side would be congruent to this side, so we've got this shaded isosceles triangle, and then this non-shaded isosceles triangle. These two sides congruent, and then this is the base. So, two things that we know about a kite. In a kite, the diagonals are perpendicular to each other. So just like in a rhombus, diagonals are perpendicular to each other. However, a rhombus is a parallelogram, which means the diagonals also bisect each other. Here, only one diagonal is bisected, which is pretty obvious if we look at it. So this piece is going to be the one that's bisected. It's cut in half. However, this piece right here is not the same as this piece right here. This piece over here is clearly longer than this piece over here, so those are not congruent. The second thing we know about kites is that the angles in between the non-congruent sides are congruent. So the angles that are congruent are the ones in between the non-congruent sides. So what do we mean by that? If these two sides are congruent and these two sides are congruent, in between the two sides that are not congruent to each other, for example, this side right here and this side right here, this angle in between is congruent to this angle in between these other two non-congruent sides. So there's only one pair of congruent angles in a kite, and it happens in between the pairs of non-congruent sides. So applying that, it says put rainbows at the congruent angles in each kite. Well, these two are not congruent to each other, so this angle is going to be congruent to the angle in between these two that are not congruent to each other, this angle. These two sides are congruent. I want the ones that are not congruent. So in between these two sides, this angle is going to be congruent to this angle. Two non-congruent sides, angle in between, congruent to two non-congruent sides, angle in between. Non-congruent sides, connect those with a rainbow. Non-congruent sides, connect those with a rainbow. And there we go. Alright, each of the following is a kite. Find all the angles. So this is similar to a rhombus. Again, we know that everything in the middle, these four angles in the middle, are right angles. And then over here, we've got 35 degrees. So to find the other angle, we take 180 and subtract 90 plus 35, the other two angles, which is 125. When we subtract that, we get 55, and this triangle down here is going to be the exact same as this one above it. These are two congruent triangles. Similarly, these two triangles are going to be congruent to each other, but the angles are going to be different than these ones over here. So in a rhombus, we have four congruent triangles. They're all the same. In a kite, we have two that are congruent and two that are congruent. So we do know that this is going to be the same, so this is 20 and 20. And then we would need to find this angle up here, which is the same as this one down here. So we add 90 and 20, which is 110. Subtract that from 180, and we get 70. Over here, now we have to figure out where the congruent angles are because we don't have diagonals drawn in. So these two sides are congruent. These two sides are not congruent, which means this angle has to be the same as this angle. So this has to be 110. And then to find the missing angle, we know that any quadrilateral adds up to 360 degrees. So we add up what we have. We've got 110, 110, and 90. 110 and 110 is 220, plus another 90 is going to be 310. So if we subtract 310 from 360, we're left with 50 degrees. Over here, same thing. We've got the non-congruent sides here and here, and then here and here. So these two angles in between are going to be congruent to each other. We don't know what either of them are, but we do have these other two missing angles. So we take our total, 360, subtract these two angles added together. So 110 plus 80 would be 190. When we subtract that, we get 270. I'm sorry, 170. There we go. So 170 degrees is left over for these two angles right here. So if I take that 170 degrees and divide it evenly by 2, we're left with 85 for each of these angles. All right, same thing, just a little bit more algebra. Here, these two angles in between the non-congruent sides are going to be congruent to each other. So we have 100 equals 4x. We divide by 4, and we get x is 25. Then we know if each of these are 100, so 100, 100, and 90. All of that adds up to 290 degrees. So I have 290 degrees between these three angles right here. I know the entire four-sided shape adds up to 360. So I subtract what I have, and I end up with 70. So y, this leftover over here, would be 70 degrees. Over here, this is tricky. We've got congruent angles here and here, which means these two sides on either side of this angle must not be congruent to each other. That means if this side is not congruent to this side, then this side is congruent to this side, because in a kite, we have to have consecutive sides congruent, two pairs of consecutive sides congruent. So if these are the non-congruent sides, these are also non-congruent sides. And this one go together, this one and this one go together. So now that we know which ones are congruent, these are the same. So we take 2y equals 36, we divide by 2, y equals 18, and then 3x equals 24. We divide by 3, and we get x equals 8. All right, a few more examples. We've got COMP. This shape is a kite. And if we scroll down a little bit farther, it says that we're trying to find the perimeter of this kite. So we know that we've got 90-degree angles here and here. So in order to find these sides, these two are going to be the same, and these two are going to be the same. In order to find these, we need something called the Pythagorean theorem, which we haven't formally learned yet. So don't worry too much about this example. This one will be more important. But in order to find this third side, we use the Pythagorean theorem, which looks like this. A squared plus b squared equals c squared, which you might have heard before. So we take these two sides, the two shorter sides, and set them as a and b. And then the longer side we call C, the hypotenuse, the one across from the right angle. So when we do all of this math, again, don't worry too much about these calculations yet. We get the square root of, since we have to figure out what C is, we take the square root of this to get rid of the squared part. So we square root the sum of these two, which happens to be 289. So when we square root that, we get 17. So this piece is 17, this piece is 17. Since this piece right here is 8 and this piece right here is 6, we do the same thing, same process, except now we have 8 squared and 6 squared equals, we'll call this something else, we'll call this f. So we'll call that f squared, and when we add these two up, we get 100, and then we have to square root that, which leaves us with 10. So this is 10, this is 10. So if I add up all 4 of those sides for the perimeter, I get 10 and 10 is 20, 17 and 17 is 34, 20 and 34 is 54. This example, first we have to figure out which sides are congruent to each other based on the angles that are marked congruent. So again, if this angle is marked congruent to this angle, that means this side is not congruent to this side, so these two are different, and these two are different, but these two are the same, and these two are the same. So now that we know these two are the same, we can just set 2x minus 1 equal to x plus 9. And we solve for x, so we subtract x, we get x minus 1 equals 9. We add 1, x equals 10. So now we plug that back in. 10 plus 9 is 19, so these two sides are 19. So we add up 19 and 19 for the perimeter, and then we plug 10 back in here. 2 times 10 is 20, plus 3 is 23. So both of these sides, since these are the same, are 23. So when I add all 4 of those numbers up, I get 84. So x was 10, perimeter is 84. All right, on the bottom here, decide whether the following are true or false. The diagonals of a kite are congruent. That is false. We talked about that earlier. Diagonals are perpendicular. That is true. The diagonals bisect the vertex angles. That is not true for a kite, unlike other quadrilaterals that we've talked about in this chapter. Diagonals bisect each other. This is only true for one diagonal, like we talked about on the previous page, so this happens to be false. Diagonals of a rhombus are congruent. That is false. The only one this is true for, the diagonals are congruent, is a rectangle. So we'll mark that one right now. Diagonals are perpendicular of a rhombus. That is true. That is not true for a rectangle. So we'll mark that. Diagonals bisect the vertex angles. That was one of the things we learned about a rhombus. Diagonals bisect vertex angles for a rectangle. That is not true. And diagonals bisect each other. That is true for both of these, since both of these are special kinds of parallelograms, and we know that that is true for a parallelogram.